Let's revisit the idea of measurement levels. Qualitative data is also called categorical data in that the data can be found in any of a number of qualitative categories. We previously saw that there are two types of qualitative or categorical data: nominal data and ordinal data. Nominal data is data that simply represents a name. In particular, the name is simply the label for the categories in which the data is located. Consequently, nominal data does not have an objective ordering, and thus, nominal data can be reordered without concern. Ordinal data also represents a categorical variable. That is to say, the data is placed into one category or another, but in this case, the categories have an inherent order in their structure or interpretation. We say that there is an objective ordering from lowest to highest, or vice versa. For example, letter grades that you might earn in a college course are examples of ordinal data. It is conveniently agreed that a C is less than a B, and a B is less than an A. So, both nominal and ordinal data represent categories, but only ordinal data has categories with a fixed ordering. Again, this means we can reorder nominal data at our will, but the most we can do to reorder ordinal data is to write it in the increasing or decreasing order. Beyond that, the categories for an ordinal variable cannot be placed in any arbitrary order. Quantitative data is generally thought of as numeric data, and the ordering of the number line applies to all such data. For quantitative data, there are two measurement levels: interval data and ratio data. We will clarify these two shortly, but first, we note that because nominal data has no ordering, it can't be grouped into coherent or non-subjective groupings. For ordinal, interval, and ratio level data, there is an inherent order, and this means that these type of data can be grouped. This means for all data but nominal data, we can calculate cumulative frequency distributions, which require grouping. Before we clarify the difference between interval and ratio data, let's clarify the distinction between interval and ordinal data. Interval data is quantitative in nature, it is numeric, and ordinal data is categorical in nature. However, it is not uncommon for ordinal data to be represented numerically, like when letter grades are presented as a grade point value on a 4 or 5 point scale. The key attribute that separates ordinal data from interval data is that we can't quantify the distance between two observations. For example, if we have two students, one with a C and one with a B, we know that the student with a C performed lower than the student with the B. Alternatively, if we have a third student that had an A, we know that student performed better than the student with a B, and in turn, better than the student with a C. What we do not know is the degree of difference between these performances. Furthermore, if the data had been presented quote-unquote numerically as 2.0 for the C, 3.0 for the B, and 4.0 for the A, this seems to suggest that there is an equally spaced 1-point difference between each letter grade. However, this need not be the case. Let's look at a couple of possible scenarios between the A, B, and C students' overall performances. Let's say the C student had an overall score of 79 and the B student had an overall score of 81. While the students have different grades, i.e. are in different categories if you will, relatively speaking, their scores are rather close, differing only by 2 points. If the A student had an overall score of 98, we can't really say that the A and B student were close in their overall performance. In other words, there is only one category difference between the C and the B, and only one category difference between the B and the A, but the size of the actual performance between the pairs are nowhere near the same. There is only a 2-point difference between the C and B students' actual performances, but there is nearly 10 times more of a difference, nearly 20 points, between the B and the A students' performances. The idea behind interval data is that the gap between each successive measurement represents a comparable distance and fixed quantification. For example, a 1-unit difference in a test score usually represents one additional question that was answered correctly. If we had two pairs of students, each pair with one A and one B, we can't say how close the scores actually were. That is the constraint of the ordinal level of measurement. However, if we have their interval level scores, then we can clarify how close or far apart their scores actually are. For example, an 81 and a 98 are much further apart than a pair of students with scores of 88 and 92. But in both cases, we are asking how far is a B letter grade from an A letter grade. which is unanswerable using only ordinal level data. In addition, when two values are equal for interval data, this means the results are the same within rounding error. However, two values for ordinal data need not be the same. As a quick example of this, if we have two students with B letter grades on a test, we do not know which student performed better than the other or if they actually performed the same. However, if we have the interval measure of their scores, say 81 and 88, then we can indeed state which student performed better. Okay, let's clarify the difference between interval and ratio level data now. For ratio level data, the 0 actually means nothing or no amount of that quantity being measured. For example, if you are counting the number of eggs given by the chickens on the farm, if you have a value of 0, that means the chicken produced no eggs. This is different from interval data, where 0 does not necessarily represent quote-unquote nothing of that quantity. The go-to example for interval level data is temperature. A temperature of 0 degrees Celsius does not represent no temperature. It is just an arbitrary point on the scale, and if it is actually 0 degrees outside, we simply mean that the temperature happens to be at that arbitrarily chosen point. Again, it does not mean that there is nothing present, that there is no temperature present. What happens if 0 is arbitrarily chosen for a scale? Well, this means that we can't talk about ratio-based comparisons. That is, we can't talk about twice of something or half of something. For example, most people would not say that 130 degrees Fahrenheit is twice as warm as 65 degrees Fahrenheit, or that 20 degrees is half as cool as 40 degrees. The meaning of the distance between two temperatures is the same. 40 to 50 degrees represents the same difference or increase as 80 to 90 degrees, but the ratio of the values has no meaningful interpretation. Ratio level data allows us to make multiplicative comparisons. We can say that one cow produced 5 times the amount of milk as another cow because the quantity of milk is a ratio level variable. To summarize, ratio level data allows us to make multiplicative comparisons. Interval level data allows us to talk about the relative size of quantitative differences. And ordinal level data allows us to put the values in order, but not to distinguish within those categories or quantify the differences. And lastly, nominal level data cannot be compared via any type of ordering.